Okay, so let's have a look at the firewall integration lab. So what we have is we have the Vyatta firewall in between, and the Vyatta firewall has 3 network connections: Ethernet 0, 1 and 2. That's what we've set up. And then this is our public network, this is private, and then this is the DMZ. Okay, so what we're going to do is we're going to set up our networks. So we're going to put our Ubuntu host onto this network, onto private, the Windows server onto the DMZ, and then we're going to connect to the default gateway, which is here. So we'll use DHCP here, and then we'll use static IP addresses for the other networks. Okay, so what you'll be allocated a network. So in this case we'll just select one of the first ones here. So we'll select 10.1.1.0 and 10.1.2.0. That's going to be our 2 networks that we're going to select. Okay, so the first thing we're going to do is that we're going to set up our firewall. In the lab we're going to use network address translation. So you should find that the firewall is able to route between interconnected networks that directly connect to the Vyatta firewall. But if we want to route onto the internet and so on, we need to use NAT, or network address translation. What we use is NAT overloading, where we can take multiple IP addresses and map them onto a single address borrowed from the public network. So when something goes out from this network, if it goes out to the public network, it will be mapped to one of the public IP addresses on a different TCP port, and then mapped back again. Okay, so the first thing we'll do is that we'll just set up our network. Okay, so let's log on to vCenter. So we'll just have a look, and you should find production, and then within this folder here you should find your group there. So what we'll do is we'll power up our Ubuntu. We'll power on our Vyatta, and we'll power on Windows. Okay, so let's have a look. We're going to be setting up our Ubuntu host first. Okay, so here it's here. So let's just log on. Okay, so this network address that we're setting up, so we'll just have a look at the IP address, and it's Ethernet 11, sudo ifconfig Ethernet 11 10.1.1.7 netmask 255.255.255.0, and make that up. And then we're going to set up the default gateway, which is the port on the firewall that we connect to. So anything that isn't destined for the local network will go to the default gateway. It's up to the default gateway to route that out. So in this case we'll make it 254. Oops. So we should be able to ping our own port first, but we won't be able to ping the firewall because it's not been set up yet. So just ping your own port, and that's fine, and this one isn't alive. Okay, so now what we'll do is we'll go on to the Windows machine. The Windows machine is on a different network. Just open that one up. Okay, and that says That's us in. And the first thing we'll do is to set up the IP address. So on this one, this is 10.1.2.7 is the IP address for this one. So let's find that, and it's 10.1.2.7 255.255.255.0. Our default gateway is going to be here, and we can set this one up to be our DNS server. Okay, so as we've seen before, hopefully our local address is set up okay, and it is. So now what we've got to do is set up the firewall. So we'll just open it up. And it's just Vyatta. And Vyatta. Okay, so then we go into configure. Right, so we start from the we can set the host name and so on, but we'll just jump straight to the interfaces. So it's Ethernet. So Ethernet 0 is going to be set with DHCP. Okay, so that's going to take the address from the gateway, and the next one is an Ethernet 1, so that's going to be private network. So this one is 10.1.1.7 in our case, and the second one is there. And there we go. So we can go and try to ping our interfaces, and you should find that you won't be able to do it yet. So let's ping our gateway 10.1.1.254. Okay, so you can see that doesn't work. So then we commit, and we can save. So now, hopefully, should work. Oh, sorry, I've set the wrong IP address. It should be 254. So let's do that again. So this is and let's delete the other one just to show that it doesn't work. Okay, let's try again. So we set this one up to be 254 for Ethernet 1, and then this one up to be 2.254, and let's do it this time. I'll just save that. Okay, this time. There you go. Okay, so our default gateway is up, and let's have a look at Windows. We'll just ping our default gateway 2.254, and it's working. So now let's ping the other host, and that's working. Okay, so everything is working perfectly now. and we should be able to have a look around. We can then, if you go ahead and delete your interfaces, you should find that shouldn't work anymore. So we can find out the MAC address of our gateways if we do ARP-A, if we've pinged them. So there's the MAC address of the interface, which connects over here. Show configuration. So there we go. That ties the same F0 there is the same as that one, and then we can go to our Ubuntu and have a little look to see if that's set up okay. Okay, so from here you should be able to now connect to each of the servers within inside each of the networks. So if I just bring up the browser here, so it's 10.1.1.7. okay, so that connects to that one, and then over here we should be able to connect to 10.1.2, 10.1.2.7. okay, just make sure that that's online, and there it's there. Okay, so we can see we've got connectivity between the two networks, but we won't be able to get connected to Google because we can't actually root out. So if we went over here, so we won't really be able to get connectivity to the internet. So what we've got to do is set up NAT. Okay, so we'll just go ahead and set up NAT now. So NAT allows us to take an IP address from the network and then to overload it onto a public network. So what we'll do is we'll first start on the private network. So we set up a rule number 1, and it's for the outbound interface is going to be Ethernet 0. So this is going to take our addresses that can be routed, and we're going to route that out. Rule 1, if the source address is 10.1.1.0, anything on that network is the source address, and then that's going to be overloaded with address masquerade. Okay, so we can do the same again for the, hopefully that's now working over here. Do the other one while that's doing that. Okay, so for this one we're going to route from that network. And from there. And that's the second row there. Okay, so it won't work yet because we haven't actually committed it. So now let's commit. Just check that we have everything there. We'll just go back here. And there we go. Isn't that great? Okay, so that's working. Okay. Okay, so that shows how we can set that up. So you may find you won't get your connectivity from here, and it's because of the name. It's a name server problem So what we normally do is that we normally have a little look just to see if we can ping the default gateway, and we can, so everything looks okay. And we normally ping 8.8.8.8.8, and that's okay. So our problem is in our resolve.config, and it's because the name server needs to be set up for 10.200.0.1. Okay, Control X. There we go. Sorry. Right. Let's do a sudo. So that's 10.200.0.1 and Control X. So this is setting up our name server. So we normally do an NS lookup just to see if that's working okay. And it is. That's looking good. So we should now have connectivity to Google, hopefully. And there we go. Okay, that's it. Okay, so that's setting up that. So what I'll do is I'll just let you look at the configuration. And we can actually see what we've set up. Okay, we've set up DHCP on Ethernet 0, set up our two networks there, and then we set up our NAT to translate from the private network into the public network, and so on. Okay. And that really sets up the first part of this lab. Okay, so now we're going to enable some services actually on the firewall. So let's just open here. Okay, so we'll just go back into our configuration mode, and we'll support. So these are the services that we can add: HTTPS, Telnet, SSH, and so on. So let's enable Telnet. And let's also enable SSH. Okay, and then we'll just commit that. So the next thing we're going to do is we're going to try and Telnet into the firewall. So we'll do that for the Ubuntu instance. Okay, so Telnet 10.1.1.254. There we go. Excellent. Okay, so we'll just log out. Now what we'll do is we'll try SSH. So 10.1.1.254. And I'll try with Vyatta, but I don't think we've set up the host name yet. Do you want to continue connecting? Yes. And there you go. So we're now into the firewall. So we've enabled the two services. What to do is to start Wireshark, and then to have a look. So Wireshark. And have a look at the capture from we've got to start it as sudo. So you should see the difference between the two services. With Telnet, we should be able to actually see the contents of the Telnet connection, where with SSH we shouldn't be able to. What's happened here is I need to put in my password there. There we go. Okay, so we're going to listen on that interface there. Just watch, there's a little command prompt that the little window that comes up there. Okay, so let's exit from there, and I'll just show you the difference between the two protocols. So we'll just stop that one and restart. Okay, so first Telnet and Vyatta. Okay, then we'll just exit. Okay, so let's have a little look at this. So normally what you do is that you right click and then follow TCP stream, and there we go. We can see it all appears in plain text. Now what we'll do is that we'll restart and we'll use SSH. Now we just stop over here, just see what we have. Okay, so this time the protocol is this SSH port 21, and if we were to look at the stream, there's an initial negotiation at the start, so that's for the basic cryptography that we're using, but you can see we can't see any of the data width inside there. Okay, so that shows you the difference between the two protocols. Okay, so I'll just quit from there, and you can have a look at the configuration to see how Vyatta actually shows it. Okay, so there's our Ethernet connections, there's our NAT, and there's the SSH and Telnet setup. Okay, so now let's set the firewall rules. We typically keep things fairly simple and define a number of domains and then define the traffic flow between the domains. In this case we'll define 3 domains: public, DMZ and private. Typically we don't allow traffic to go from the DMZ into the private network unless it was initiated in the private network. Same with the public network, we don't allow anything from the public network into the private network unless it was originated from the private network. Okay, so let's start to configure it. Okay, zone policy, zone, and then private, and description, and that's inside. And then this one is our public. The name that we put here is what we're going to be using. that's outside. And then for the last one, it's the DMZ. I'll just give a basic description so that we know where it is. Zone policy, and it should now pick up the names. Zone policy, zone. Okay, so it should pick up the names. So let's go for the public network first. That's on interface ETH0. Okay, let's delete that one. Looks like it's been set already. And let's set up. Okay, private. It's ETH1. And then our DMZ is here on Ethernet 2. Okay, so that's our zones. So you should find that we'll still be able to perform. We should be able to access our services. So, for example, okay, so then the way that we normally do this is telnet, and then this is 10.1.2.7, and let's see if we can access the web, and we can. Okay, so let's try telnet. It's looking good. Okay, and we can. So we do the same with each of the protocols. So then we would do port 21 for FTP and port 25 for SMTP. So all our services are working fine there, and we can do the same from the Windows side. So we'll now define our policy. Okay, so this is DMZ2. Private rule 1 action. And what we're going to do is we're going to accept that's rule 1, and what we're going to do is we're going to accept connections coming back if they've been established with inside the network. Okay. So the firewall must remember the rules that the connections that it made. Okay. And then sometimes there are protocols which open up other ports such as FTP, so it needs to remember these, so we'll enable them related. Okay, so now that's allowed us to define the flow between the DMZ and the private network. what we'll do now is define the flow between private and DMZ. Okay, so we're going to accept any established connections and also related ones. Now what we'll do is that we'll actually set up the connections that we're going to allow, and it will reject all other ones. So we're going to accept and for our destination port 80 and port 443, the two HTTP ports. And then we're going to find that just for TCP. Okay, so we now have two rule sets set up. So what we're going to do is that we're going to apply our policy. So up to this point, our firewall won't actually block anything until we apply this. Okay, so this is from the DMZ to private, and we're going to apply that rule there. Set zone policy zone private from DMZ firewall name from DMZ from private okay, so we've now applied our rule set. So we'll go ahead and commit that. Okay, so let's have a look over here. Okay, port 80 is still working. Port 23. There you go. It's not working anymore. So that doesn't work. So we've managed to firewall that one. And we'll try port 21 again. It doesn't work. And as if by magic, hopefully 443. Alright, that the 443 is to do with the 443 not being enabled on the other side. But what we've managed to do is that we've managed to, so we should be able to use the web browser to be able to access the other side. 10.1.2.7. There we go. But we now find that port 21 has now been blocked. So all ports have been blocked apart from port 80 and port 43. Again, so we should be able to see that from our config. Okay, so rule 10 says that we accept port 80 and 443 and all other ports will actually be blocked. Okay, on the other side we can have a look to see which ports are blocked.